Okay, well, if you're seeing this, I probably just had surgery. All right, uh, here we go. Do you remember circumference and area from back in the day? Circumference was 2 pi r. That's the formula for it. Okay, circumference is finding the actual distance all the way around a circle, okay, around the edge. Okay, it's like you had a circular measurement. Area, of course, is everything inside, right, of the circle, and that's pi r squared. 2 pi r is one formula for circumference, and pi d is the other one, but we usually use 2 pi r. Okay, so if this was 10 for the radius, then we would plug it in here. 2 times 10 is 20 pi. Or you could say 20 times pi in your calculator. So if you looked at, see where that little caret thing is right there? That's a caret, that rooftop. Okay, right above it is pi. So you hit second pi. So if you said 20 and then second pi like that, you could hit enter and you would get 62.8. Okay, just remember that's an appropriate answer, that 20 pi right there. Okay, and 62.8 is what you see as well. But this one's more exact. This one is okay. No problem. All right, so if this one was 10 and we were trying to find the area, we would say pi 10 squared. You know what 10 squared is? It's 100. 100 pi, okay? Or 100 second rooftop, and that's, you know, the best way to go probably. So 100 pi is the exact. This is 314.2, which is the approximate. So either one would work. All right, so today's lesson is going to be about, okay, arc length and sector area. Okay, arc length is, as you know, an arc is part of the arc. Or part of the circle. So part of the circumference, really, to be more specific. So this marking right here is the arc. Now we're actually going to start measuring. You remember before we had central angle and this was 60 degrees out here. Okay, now we're actually going to measure the length of the arc in inches or centimeters or whatever. And then sector area is another thing that we're going to do, and that's where it's the piece of pizza. It's that little sector, okay? So we're finding the area of that sector, so we have to know what part of the circle we're using, and we find the sector. Okay, this is the crust of the pizza. This one is the area of the sector. Okay, so arc length and sector area have different formulas. Okay, so let's go on to the notes, which you've already got filled out, which is kind of nice. All right, so let's start. So in previous lessons, we found measures of arcs in degrees. Okay, notice how we've got circumference over here, the formula, area of the circle formula, and then we've got the arc length and sector area formulas over here. Okay, so now we're going to actually find the actual arc length. Okay, arc length is a fraction of the circle's circumference. So we need a part of the circumference, okay? All the way around is 2 pi r. A fraction of it, we would have to do this formula, where we're doing the degree measure part of the 360. All the way around is 360, so part of it is what we need. Like right here, if, say this was 60 degrees, this was right here was 60 degrees, and so we would want 60 degrees out of 360, and that's what this would be. So we plug in 60 degrees there. So this right here tells me the part of the circle that I want, okay? And you're going to multiply it by the circumference, okay? So if you multiply by the circumference, well, you'll get the part that you need. That's the arc length from A to B, okay? So right here, let's say the part, okay, or the fraction that we're trying to find of the circumference, okay? So the circumference right here, the circumference, we want a fraction of it, okay? So 60 out of 360 times the circumference, all right? Well, let's look at a problem. Maybe that'll help, okay? So if we want to find the actual distance from A to B, then what fractional part am I using, okay? There's your arc up here. Let me bring this down just a little bit so you can see. See that right there? The arc out of 360. So it's 120 degrees out of 360. If I reduce that, it would be 1/3. So I'm looking for 1/3 of the circle's arc length. Okay, 1/3 of the whole circumference would be the arc length. Actually, is a better way to say it. Okay, so 120 out of 360 times 2 pi r. Okay, 2 pi r is the circumference. All right, so basically we need r, which is 10, and we plug in a 10 right there, so that's 2 times 10 is 20, so that's 20 pi. Okay, 120 out of 360, I'm going to write it again. Okay, basically that's the part that I want, which is 120 degrees of it, of the 360, times the 20 pi, which is the circumference. So we just use the calculator. We say 120 divided by 360 and hit enter, and that's, as you can tell, that's 1/3, right? Okay, so I take that, I hit enter so that I could now multiply it by 20 pi. So I say times 20 pi, and I get 20.9. Okay, so that's the actual arc length from A to B, how long it is. Okay, if I wanted the whole circumference, I'd just do 20 pi by itself, but I only want 120 out of the 360 degrees. Okay, all right, here's example number 2, arc length. Okay, so I'm trying to find this. So what part of 360? What's the ratio that I need, or fractional part that I need? Well, I want 60 out of the 360 degrees. Okay, and then I multiply it by what? The circumference. Okay, that's the circumference. Okay, that's all the way around. This part right here, 2 pi r, is all the way around. And then 60 out of 360 is the part that I want, okay, which is the A to B. So 60 out of 360 times 2 pi r. Okay, so I need the r, which is 6. I'm going to plug that in there. 2 times 6 is 12. And then you got the pi. So you take 60 divided by 360, okay, times the 12 pi. So can you see it? Yeah. 60 divided by 360, hit enter, okay, and then times 12 pi, and you get 6.3. Okay, so that's the actual length from here to there, from A to B. Okay, so part of the whole, that's the part of the whole that we want, times the circumference, right? So all the way around is this part, and this is, I just want that little bitty part right there, so 120 out of the 360, right? It looks more like that if you look at it like that. All right, so moving on, that's arc length, okay? Sector area is finding the area of the sector. See how it's the whole, the piece of pizza? So we're trying to find the area of a sector. So it's exactly the same, except for one thing. We find the area of the circle, and then we want the fractional part, okay? The fractional part that we multiply by. So we still do exactly this, where we do, like on this one, it's 30 out of 360, right? So you'd put 30 here out of 360, but we multiply it by the area. So the whole area would be everything shaded in, right? And then 30 out of the 360 would be like this, 30 over 360, and then you'd multiply it by the area, which is pi r squared, right? So r, we know, is 6, so we're going to plug the 6 in there. So 6 squared pi. Okay, 6 squared is 36 pi, so I'm just going to rewrite it, 36 pi. And that's all of the area. That's as if every part of this was shaded completely. But I only want 30 degrees out of the 360, so I say 30 over 360, right? And then I multiply this by the whole area, and I get the part, the sector area, which is the piece of pizza, okay? So 30 divided by 360, I hit enter, and that's the fractional part in decimal form, times 36 pi, and that's 9.4. So that's the area. Let's say this was inches. If it was inches, I would say inches squared because it's area, right? Okay, 9.4. All right, this one's a little trickier. They didn't give us the radius, did they? No radius. But they did give us the area of the circle. So if you think about it, we've still got the same fractional part that we're looking at. We're trying to find the area of this part, right? area of sector. Okay, so that's 120 out of 360, right? And then if we want the area of this whole sector, then this part was supposed to be the area, right? Okay, area of the circle. Well, guess what? They told us what the area was. It was 100 pi, so all I got to do is plug that in here. And it was an easy problem. I thought it was going to be hard, but no, it's easy. 120 divided by 360. You hit enter, and then you multiply it by 100 pi. And you get 104.7. And if it was in inches, we would say inches squared because it's area. Okay? All right. Last one kind of combines everything. They made it kind of weird because this is the part that's broken off, that 200 degrees worth, right? This is the shaded part, right? So circumference, we remember, was 2 pi r, right, for a formula. So radius is 10, so I'm going to plug a 10 in there, and I'm going to put 20 pi. Now I could multiply that and say 20 pi like that and get 62.8, but you know, that's a really good answer right there. I like that answer. Okay, the area of the circle, okay, we know that formula is pi r squared, right? Okay, the 10 is the radius. We plug a 10 in there. Let me do it over here. Pi 10 squared. Okay, 10 squared, isn't that 100? 10 times 10? So that's 100 pi. Of course, I could probably punch it in and get a number for that, like 314.16259, something like that. Anyway, or I could just leave it like that. Okay, arc length is where we do a part, okay, this part right here of the whole circumference, right? Circumference is all the way around, which is 20 pi, okay? And then we only, basically what we're trying to find is this JRM arc, okay? So that's 200 out of the 360 degrees. That's the part, the fractional part that I'm looking at, okay? 200 divided by 360 times 2 pi r. Oh, haven't I already done 2 pi r? Yeah, I have. I did it right there. It's 20 pi. I plugged in a 10, and 2 times 10 is 20. So this is 20 pi. I've already got the circumference. I already calculated it. Okay, so now I just put it into the calculator. 200 divided by 360, hit enter, times 20 pi, and I get 34.9. Very nice. Okay, 34.9 is the length from J all the way around to M. Okay, that's the arc length. Now the sector area is the blue part. Okay, the blue part that's shaded, that's the sector area. So once again, isn't that 200 out of 360? Sure it is. 200 out of 360, and then this is supposed to be pi r squared because it's supposed to be 200 out of 360 of the area of the whole circle, but I've already done that. I did pi r squared already. I plugged a 10 in. See that 10 right there? I plugged it in right there. It was 100 pi. This is supposed to be area of the circle because this is a part of the area of the circle, so I just go ahead and plug in 100 pi. Oh, it looks like he's looking at something. Anyway, so 200 divided by 360, hit enter, times 100 pi, and I get 174.5. Okay, and if it was inches, we would say squared. Like up here, we would say inches squared for that one. Anyway. But that's it. You know, these are, you know, it's not hard. All right. See you guys later. Have a good time while I'm laid up.